In this video, we're going to talk about limiting reagents. In a chemical reaction that goes to completion, for the reactants we have two possibilities. One is that we have stoichiometric amounts of our reactants. That means we have the exact ratio that is needed for the reaction to go to completion. There will be no reactant left over. That's one possibility. The other possibility is that one reactant is completely consumed and that the other reactant has some amount unreacted that's left over. It is in excess. So those are our two possibilities. While we like all reactions to proceed the first way, that we measured out exactly the right amounts to react everything up so that there's no waste, the vast majority of the time in the lab, that's not going to be the case. That one of the reactants will be left over that will be in excess. The limiting reagent, as its name suggests, limits the amount of product that is formed. It is completely consumed. Whereas the reagent in excess, that's my little symbolism for it, XS, that the excess reagent is not completely consumed. There's some amount that's left over after the reaction is completed. It's not completely used up. The reagent in excess does not determine the amount of product. It's the limiting reagent that does so. So let's look at this reaction. 2 moles of hydrogen plus 1 mole of oxygen reacts to make 2 moles of water. And let's say we have 10 grams of molecular hydrogen and 20 grams of molecular oxygen. And we want to find out how many grams of water we can make. What's our theoretical yield of water? So what we're going to do is we're going to take both reagents all the way through our process, see how much water can be produced based on each reagent, and then compare our answers. At the end, there'll be one of them will have the lesser amount, and that will have come from what the limiting reagent is, and that will be the answer to our problem. So for both reagents, we want to go from grams to moles to moles to grams. Whenever we go from grams to moles, we want to use the molar mass. Or if we go to moles to grams, we need the molar mass, the reverse process. That middle step of going from moles to moles, we're going to use the stoichiometric ratio. So let's first do hydrogen. We've got 10 grams of molecular hydrogen. We want to convert that to moles of H2. From the periodic table, we can calculate that it's 2.02 grams per mole hydrogen. So now grams hydrogen cancels, we got moles hydrogen. We now need our stoichiometric ratio. We want to get to moles water per moles H2. And from our balanced chemical equation, is 2 moles water produced from 2 moles of molecular hydrogen. Looks like a redundant step since the 2's cancel out, but it's important to put that stoichiometric ratio in there. We want our units to cancel out. We want to make sure we're doing this correctly. So moles H2 cancels. And now we want to come up with our mass of water. So when we cancel out moles water, and 1 mole of water is the same as 18.0 grams of water. So plug that in our calculator. 10 divided by 2 times 2 divided by 2 times 18 will give me 89.1 grams of water. Now we need to do the same thing, but based on oxygen. So 20 grams of molecular oxygen, we want to convert that to moles. 1 mole of O2 is the same as 32.0 grams of O2 from the periodic table. Grams oxygen divided by grams oxygen cancels. We got moles oxygen. Now we need our stoichiometric ratio, that 2 moles of water is produced from every 1 mole of oxygen that's consumed. Now moles oxygen cancels. We're left with moles water, but we want to get that to a mass of water. So 18 grams of water is the same as 1 mole of water. Moles water cancels, and we're left with grams of H2O once again. So 20 divided by 32 times 2 times 18 will be 22.5 grams of water. So now comes decision time. Which one's our right answer? And the lesser amount comes from the limiting reagent. So our limiting reagent in this problem is molecular oxygen. And our reagent in excess, the one that we have more than enough of, is H2. And so our correct answer is 22.5 grams of water. So the really important thing to point out is, if we go back and look at our masses to begin with, we have to remember that reactions don't take place on a mass-to-mass basis. Because if you looked at the two masses, you go, there are only 10 grams of hydrogen versus 20 grams of oxygen. Hydrogen must be our limiting reagent. But that's incorrect. You have to look at it on a mole-to-mole basis. And so when we go through this process, converting things to moles and taking into account the stoichiometric ratio, that bridge factor between moles and moles, it turns out that actually the greater mass from the reactant here has the lesser number of moles, and so O2 winds up being the limiting reagent, whereas H2 was our reagent in excess. We could go back and see how much hydrogen we have left over. Remember, we wound up with 22.5 grams of water. We started out with 10 grams of hydrogen and 20 grams of oxygen. And we said our oxygen was our limiting reagent, so all of that's consumed. And so we had 10 grams of hydrogen that was totally reacted. So the law of conservation of matter says that the mass of our reactants which is 10 grams plus 20 grams equals 30 grams, has to equal the mass of our products, which is 22.5 grams, but we used up all 20 grams of oxygen, which means we only consumed 2.5 grams of hydrogen. So if we go back to the amount of hydrogen we started out with, minus 10 grams of hydrogen minus 2.5 grams, that means we have 7.5 grams of hydrogen unreacted. We did this using the law of conservation of mass. Now, if you want a further proof of that, we could take since we know that oxygen is our limiting reagent, 20 grams of oxygen, 1 mole of oxygen is the same as 32 grams of oxygen. We're wanting to get moles of hydrogen now, so we want to convert to moles hydrogen from moles oxygen. So it's 2 moles of hydrogen to 1 mole of oxygen. And now 2.02 grams of hydrogen per mole of hydrogen. Grams oxygen divided by grams oxygen. Moles oxygen divided by moles oxygen. Moles hydrogen divided by moles hydrogen. That gives me grams of hydrogen. So 20 divided by 32 times 2 times 2.02 gives me 2.5 grams of hydrogen that was consumed. And that's what we had predicted up above. So this last little bit is taking this problem to much deeper depth. Make sure you understand the first 2 pages very, very well. And once you do, you might want to come back and look at this 3rd page again to see if you're following all the stoichiometry, you're following the logic about using the law of conservation of mass. Thanks for watching.